For jumping on to the call to the webinar today. We're excited to talk about this topic with you. It's been a very hot topic that people have been discussing in the last couple of years, and we wanted to bring some clarity to some of these things that have been in the industry, things that folks that have maybe had some misconceptions and some misunderstanding about some of the changes that we've seen lately, and how we're going to be recommending to deal with some of these things in the future. So we're going to talk about Type 1L cement, or otherwise known as Portland Limestone Cement, today. How to properly use it in today's concrete mixtures, and do what we've always done, which is if you treat concrete properly in the design, construction, and maintenance, regardless of what's in it, you can get a very long-lasting product. So we're going to get back to basics in some of this, in some ways, as well as promoting what we've always talked about, as far as treating concrete and using concrete and placing it properly. So my name is Steve Walkus. I've been with the Concrete Association here in Michigan for 19 years, and in the industry 6 years prior to that. So over my 25 years of experience have all been in concrete. So I have worked in this space for my entire working career, and excited to talk with you today about this topic: proper placement, finishing, and curing of concrete mixtures that contain Type 1L or other types of blended cements. So we'll get started here. What we're going to talk about, in general, the overview, the agenda for today's discussion. Why was the switch made to Type 1L by a majority of the cement producers in our region, Great Lakes region, as well as throughout the country? We'll have some data on that and talk about why as well. A switch was made. What makes it different? Nuanced, slight differences in mixtures that contain Type 1L cement versus the old Type 1 or Type 1-2 that had been prevalent in our market, in our industry, in our area and region of the country. How it may be different, how it affects the concrete mixture slightly, differently than other cements in the past, and then what we are recommending attention be paid to certain aspects of the concrete construction process, and other things, so that we can achieve durable mixtures, which we definitely can with this type of cement, as well as any other cement that is available in our market. So if anybody does have any questions as we go along, as we move through this agenda, it shouldn't take more than an hour. But if you do have some questions that may extend it out to an hour or over an hour, but feel free to use the Q&A section on the Zoom webinar controls bar, or type something in the chat if you want to send something specifically. But the Q&A is probably the best way to pose a question, and then we'll have Heather interrupt me, and then we can address that question at that point in time. So feel free to type that in the Q&A bar and send it as quick as we can, so we can cover it while we're still on that topic. So, all right, let's dive into it. Why the switch to Type 1L? Well, first off, you got to know a little bit about cement production in order to understand why a switch was made. So in a cement kiln, pictured on the top right there, it's a horizontal kiln that rotates. It's on slight bit of an angle, so as the fuel and the ingredients are put in, and everything melts to a molten, volcanic lava type of consistency, it actually has a certain amount of time it travels through that kiln, being that it's on a slight slope from where the materials fed into at the top of that slight slope, and then goes through that kiln in a certain amount of time. But those raw materials, the majority of what goes into a cement kiln is a carbonate material. Calcium carbonate is fairly plentiful throughout North America. So, that's the primary ingredient is limestone, which is typically the mineral that we have readily available to us that has that calcium carbonate that we need. That is kind of the workhorse. The main part of cement is the majority, as far as its constituents, come from a limestone product that goes into the kiln and changes chemically through that very high temperature process. Through that process, though, the CaCO3 calcium carbonate, you drive off CO2 in that high temperature environment, and then you're left with CaO. If you do the math on that, CaCO3 minus CO2, driven off actually as a gas chemically through heat, though, then you're left with CaO, which is lime, which is with all the other ingredients that go into a cement kiln. That lime is chemically combined with the other ingredients that are fed into the cement kiln and makes what we know as Portland cement. But that molten material, like I said, majority of it, the raw ingredients that go into it at the beginning is limestone. We also have to have iron and silica and alumina and these other compounds, right? And the various other ingredients are fed in to provide those at the desired amounts based on what the chemists and cement experts have deemed, to use as their raw inputs. The molten material, though, as it's chemically combined into one product, one mineral type of product, is rapidly cooled at the bottom end of that kiln. And as it comes out, it's rapidly cooled and actually goes from a liquid back to a solid then. And when it hits the ground, it's kind of an aggregate type of particle, and actually makes a clinking sound, which is then the folks that, invented this whole process then termed that as clinker, because that's literally the sound it makes after it's cooled and falls on the ground. So they collect that clinker and then they grind that up into a powder in a mill, that's fed with that the raw ingredient to the mill is now the clinker plus some other things, gypsum to help control the set, and maybe some other fillers, such as raw limestone that didn't go through the kiln. And then those steel balls, you can see them in that picture, bounce around as that mill is turning at a high rate of speed, and those very high strength steel balls bash all those ingredients into powder, and grind it down into a powder. So the old Type 1 cement that people were familiar with fell under a specification called ASTM-C 150, which limited the amount of limestone added to the mill to 5%. So we're talking about limestone, raw limestone that did not go through the kiln, that's then added to the mill with the clinker and with gypsum, calcium sulfate, for those chemistry nerds, like myself, that want to know, the calcium gypsum is used to help control the set. They do a certain amount of that. The limestone is essentially an inert powder. It does have some benefits to the cement hydration process, but it was limited to 5% under old specifications. ASTM C 150 has been around for 100 years or so. Blended cements fall under ASTM C 595, and one of those types is Type 1L. Type 1 being that it's very similar to the old Type 1 of ASTM C 150, but the L meaning that it has higher amounts of limestone. And in that case, that specification allows up to 15% underground limestone introduced to the mill, obviously with the clinker and whatever other ingredients the cement manufacturer puts in to help control their product. So that's the main difference. Why did we switch to Type 1L? Cement manufacturers for every ton of finished cement, could save up to 10% in CO2 emissions, for every finished ton of cement powder that they're shipping. So it's a lower carbon product. It lowers their carbon footprint. That was the trend, 4 years ago. And so everybody started moving gradually towards that, which brings me to my next slide, in that it was not necessarily an automatic switch 4 years ago. We started seeing an uptick, and then rather dramatic uptick, obviously, from that, with the further discussions with the administration at the time and about incentives to lower carbon materials and things like that. So prior to that, though, we were trending as blended cements as a whole, of all cements being used in the country, in the U.S., around 2 to 3% of cement produced was a blended cement of some sort. Not necessarily all Type 1L. There's other types of blended cements available that fall under that specification. But still, the majority was Type 1 until we hit 2022, and started seeing an uptick in the year 2022. And Michigan followed that trend. This is a national graph of all cement shipments in the U.S., but Michigan definitely followed that. In fact, by the 2024, 2025, we are well above that 60% that you probably see now. I don't know what it is now, and things may change from here on into the future. That's outside of my purview, but we could look back and in the future and see what has happened. At least in the recent past, you can see in the last couple of years, a large majority of the U.S. producers switched to that product. So but it was not an automatic switch. It was kind of once your competitor is doing it, you take a look at that and decide whether you want to, produce a similar product. That's typically what's done all the time in the marketplace. So, okay, so that's where we're at. Much of the Great Lakes region is using Type 1L. There are other cement types being used or available, and that the market determines, demand and supply and price and all those things determine what's used where and things like that. So that is obviously the decisions that companies make on a daily or periodic basis. Now that it is here and has been used for the last couple of years in Michigan, we've had some history with it. What is different about it? We know we weren't sure what exactly would be different about it when it was implemented, and that's kind of why we're at where we're at. But we've learned some lessons, and so that's why we're going to talk about that today. But obviously, there's more limestone in it. That Type 1L, that L meaning limestone, allows more limestone. There's going to be more of that inert limestone powder interground with the clinker and the gypsum and any other grinding aids or whatever the cement companies decide or are allowed to per specification, to put in there. So, but that's the biggest thing. There's more limestone powder. In doing that, with there being less clinker, the actual workhorse of Portland cement, the main thing that actually gets us concrete, gets us strength, that's everything else, means they typically have ground these Type 1L cements finer. So if you are a fan of looking at mix designs and mill reports and all those things, you're a concrete nerd like myself and want to dig into it, you can look at those mill certs and look at the Type 1L mill cert for a particular company versus a historical Type 1 that they probably produced in the past, or you have some filed away, and you can look at the Blaine, which is a measure of the fineness of the cement, and a higher number means it's finer. I mean, that same weight of material spreads out over a larger area, if you want to think about it that way. But it's a much finer material, and a higher number, it's ground finer. They've done that typically so that it acts similarly to the Type 1 of that they would produce at that plant. Prior to that, they want to try to provide a product that acts and performs similarly, but in order to provide that strength gain similarly, they typically have ground them finer. Also, limestone is slightly softer than clinker, so it typically is the limestone particles themselves are ground a little finer. If you were to actually be able to identify each individual cement particle that's in that powder and classify it as limestone or clinker or gypsum and all other different, you could generally the particle size on limestone is a lot finer than the average or typical particle size for the clinker, the actual Portland cement portion of it. So it's what they call preferentially ground. Limestone is in a mill at a cement plant. So a lot of the fineness comes from the cement, but this comes from the limestone, but the cement is finer too. What does that do to concrete? What makes Type 1L mixtures different than in the actual concrete? Particularly the fresh concrete here. Typically, that fineness from the cement slows or reduces or then has no bleed water, any of the above. And then also then that plus the strength gain issues, I shouldn't say issues, the strength gain differences changes timing on finishing, as well as some of the strength gain and saw cutting issues, perhaps as a result of that. So we'll get into some of these in a minute. So don't have all your questions stacked up on this slide just yet, because we're going to expand on some of that. So I mentioned bleed. If you're a newbie and have not placed a lot of concrete, seen a lot of concrete placed, let's just review what does that mean. Concrete bleeds. Does that mean it sweats and perspires, or it does all these human type things? No, bleeding is actually just in the fresh concrete. It's essentially settlement or sedimentation of the heavier particles in the concrete that's already been placed consolidated, struck off, at least to the desired level initially. Maybe it's not completely finished as far as its final surface texture, surface height, surface finish, whatever. But what happens is all of the heavy particles settle out. In a liquid, when you throw a rock into a pond, it sinks to the bottom, right? So fresh concrete is a liquid, has water in it. The heavy particles will have a tendency to sink out and settle out, and that's essentially what's happening. The concrete's not bleeding, allowing water to. It's not lighter than gravity. It's not escaping up. Everything else is actually settling out. And typically, air would come out. However, air bubbles are typically small enough, they're held in suspension throughout the concrete slab due to the surface tension of water and air and things like that. So that's generally not an issue for air bubbles to escape in an purposely air entrained exterior concrete mix. But the fineness of the cement, and type 1L being slightly finer probably than its type 1 counterpart, as well as the presence of air entrainment can affect bleed, and fibers in the mix can affect bleed. The specific mix design can affect bleed. The aggregate type or shape can affect the bleed rate. All these things combine to affect the amount of water that might bleed out, the actual how much water was mixed into the batch at the beginning or when it showed up on site, if it's in a ready mix truck, and you can adjust that. All these things affect the bleed rate. There's so many factors that go into it, but fineness of the cement is one of those factors. So if that changes, bleeding will change. All right, so we've seen it from the side on that core. I'll just go back to that one a second. You can see the bigger, heavier particles have settled out, the coarse ag. Then there's sand, and then you can see some of the fines up at the top of that core or chunk of concrete, whatever it is. What does it look like in the fresh concrete? It's rare to find, especially with type 1L. And even prior to that, I have not seen a lot of projects that bleed unless they, for some reason, had a very high water cement ratio. But we did have a photo from our files that I pulled. You can see this slab, it has the water on top. Like it wasn't there originally when this slab was struck off, and looked like it's even been edged along those forms. You can kind of see that line. So that's already occurred, but that bleed water is showing up on the surface, kind of puddling. Looks like it puddles up on the surface. So that isn't, the photo is a classic example of bleeding. But again, the finer cements, other supplementary cementitious materials, SCMs, affect bleed rate, or slow it down, reduce it altogether, hold the water in place. And so why is that an issue? If we have slow bleed or less bleed or no bleed, well, slower bleed rates, if it's just slowing it down, and we're saying it does, what could happen is you could, on an interior slab particularly, get on it to start putting that final finish on it, nice smooth, power troweled finish. You might get on it too early if the bleed is still going to come. That'll then, if you get on it too early, and densify and harden that surface, and nice smooth warehouse floor or garage floor, pole barn floor, ice rink, whatever. You could trap bleed water below that paste that you're finishing, causing potential delamination. So that could be a concern. If the bleed is occurring, it's just occurring slow. What if you don't have any bleed water, or it is just way less than what you thought, and it's never really going to affect the finishing operations? Well, then in that case, maybe you are going to wait for it because you think it's going to come eventually, but you're waiting and waiting and waiting, and it never comes, or it just comes too slow. And then what happens is, especially on exterior placements, even if it's an interior slab, but it just doesn't have the building around it yet for control of wind speed and moisture and temperature, or if it's an exterior placement, this is always a concern in exterior concrete. Evaporation can occur, and then that lack of bleed water to replace any water that's evaporating from the surface allows that top surface to dry out, and leaving unhydrated cement particles, which means weak. If it's not hydrated cement, it's literally just a chunk of powder. It hasn't turned into that glue that glues concrete together, right? So if you don't have the water to chemically react with the cement, then that unhydrated cement is weak. It's porous. It hasn't infilled, and it allows things to get in the future over the winter, perhaps, and cause damage, which then makes it susceptible to scaling. And we'll get into scaling later. But those are things that the bleed water could affect. And those are concerns that you may see on a product. Not always, but just know that this is a change, and so has changed the mixes that we see. All right, so given that, how do we counteract that? What do we do? Number one, start with adequate water cement ratios. So I suggest typically a 0.45 max, but you don't want to, if you're at a 0.45 max, you don't want to hold back a lot of water and batch it at a 0.40 and then have them mix in water at the site or have to add water on the surface then to try to get it to, because then that's not mixed in throughout and it's only on the surface because they're trying to close it up, things like that. So stick to your as close to your mix designs as possible and provide what you can that requires very little adjustment on site. All right, you may need to adjust some though. Once you're at your desired slump and water cement ratio, you haven't exceeded your max water cement ratio for that particular mix, try not to add water. Okay, try not to keep stopping during discharge and add water. I know it's not allowed on most specifications, but I see it all the time on jobs where there are no specifications or there is no inspection. They offload 3 yards to this sidewalk and they go down the road and they offload another, 3 yards to another piece of sidewalk of that, full load of concrete or whatever, and they water it up prior to that next point of discharge. Don't do that. Don't add water to the surface. I see that as well. Finishers doing that. They want to close it up. They want a good looking surface. And water is not necessarily your friend if you need that all the time to aid in finishing. Elevating the water cement ratio reduces the strength and increases the porosity, and it's a higher chance of that surface having issues in the future. Instead, use higher amounts of water reducers. Again, use more water reducer, a different type, or up your dosage. Batch it at a 0.43 and a 4-inch slump, whatever the contractor wants or is allowed in the spec, or etc. Leave a little bit of room maybe to add some water, but hopefully they don't need to. But try to achieve what you need with chemicals. And I like to call water reducing admixtures slump enhancers, because the average finisher, concrete finisher out on site, they don't really know what a water reducer does. They think you're then taking water out of the mix and giving them a lower slump, a harsher mix, a drier mix, and they don't want that. They don't want water reduction. Obviously, they've got a 5-gallon pail and a brush full of water that they're trying to add water. They like water. They want higher slump. Finishers do. So instead of, I think we need, as an industry, need to change water reducers to the word slump enhancers, because that's really, or finishing enhancers, something like that, because I think finishers, the actual concrete finishers on the job would be more apt to ask for it from their suppliers if we called them that, to achieve the workability that they want. So, but that's just what water reducers do, is they just change the particle charge on cement particles in the presence of water, and so that they repel each other instead of attract each other. It doesn't use any additional water, just makes it more, it's just makes it less sticky, I guess is how I'll say it, the mix. Speaking of adding water, most specifications, again, if you're working on a job that has specifications and inspection and everything else, prohibit adding water to the slab by spraying with a wand, brush, or other methods. You are typically often allowed to do a wet burlap drag if necessary. So a lot of the paving contractor side of the industry will typically have a machine that has that mounted on it. And they try to keep that burlap wet. They'll spray it, make sure it maintains its moisture, so it's not pulling water out of the surface or creating bubbles as it's being dragged. So that is a way to kind of get that water on the surface at an even amount, or at least keep the surface moist before the next finishing operation. Ready mix jobs, obviously we can adjust a truck. Many times, the truck is batched with a little bit of holdback water so that there is quote unquote room to adjust to bring the slump up or increase the water cement ratio. Um, but definitely keep an eye on that. Don't exceed your max water cement ratio. Check weights on the batch tickets if those are printed on there. If water is added, it needs 30 revolutions to be fully mixed. We want that water to get in through the full load of concrete, not just on the top where it's added. And remember, if you add water to concrete, 1 gallon per yard, it will increase the workability about 1 inch as far as slump measurement is concerned, but it will lower your strength approximately 200 psi. Okay, so you're going to get a strength reduction. You're going to get increased shrinkage, drying shrinkage, because that water isn't actually needed in the concrete. It's just going to evaporate at some point, leaving a void behind, and the concrete's going to want to shrink because of that change in volume. So increased chance of cracking is something that that additional shrinkage can cause. And then a big thing, it's going to, especially if it's only added to the surface, finishers need to watch this. It increases the permeability up to 50% by adding that 1 gallon per yard. And that's mixed in. If they add to the surface, it's directly just on the surface that is more permeable then. So watch that addition of water to concrete. We need water, but we only need a certain amount. All right, finishing, how does that play into things? The purpose of it is to remove small imperfections in the surface. We want a tight surface with very few, voids or holes. But again, too much is too much. And extensive finishing can then damage the integrity of the slab or the surface, really more than anything. Not the full structural integrity or load carrying capacity, but what we all see, drive on, walk on, look at, and judge it based on its appearance is the surface. So try to minimize the addition of water during the finishing operation. So what we tell folks is touch it as little as possible. You have to do the minimum amount as far as placement, consolidation, strike off, finishing, texturing, etc., curing. We'll talk about that, but try to touch it as little as possible. The more we manipulate that surface, we're not necessarily making better concrete. So what I recommend to people is consolidate and strike off. That paver is doing, in this example, is doing a lot of that work with a machine, which is good. But regardless of whether you have a paver or other types of equipment, consolidate it, strike it off. In this case, they're going for, ride quality. So they've got that long straight edge on a handle to try to cut off bumps and see if there are any dips in that as they move the straight edge from side to side across that lane or 2 lanes that they're paving. And so that's that's fine. It's not really a finishing operation. It's more of a smoothness checking operation, but it does help cut some bumps and find some voids or dips or bird baths. And then bull float. You can see that in the foreground, right near where some of the broom or groove texturing has been put near the edge. So yeah, it's placement, consolidation, strike off, bull float, texture, and cure. Basic. You do not need to get out on knee boards and hand floats and be scrubbing this thing. Just touch it as little as possible. That's what we recommend. And after that final texture has been put on, make sure we cure it like we see in the picture here. If it can't be finished right away, if there's a long distance in between placement and then some finishing operations, or the finishing and then the texturing, or the texturing and the curing, spray it with an evaporation retarder. Try to get a film on there that will prevent the evaporation. And then the minute you start working it with the next tool, that evaporation retarder, that film is gone. And do not use it as a finishing aid. Well, that's the next bullet point, which is if you look like you need water during finishing and you don't want to add water because you're concerned about shrinkage, you're concerned about permeability, water cement ratios, you're concerned about potential for scaling, we recommend using a colloidal silica finishing aid instead of water. So a non-water to be used in the finishing operations, such as a colloidal silica. There's a lot of different proprietary products out there. Number 6 there says, be checking your evaporation rates. And then based on evaporation rates, you may need to get on even before 30 minutes of texturing. But there are some simple tools out there. It's portable handheld weather stations, $300 to $350 for a little one. We have one here in our office, for example, that can tell you what the wind speed is, can tell you what the relative humidity is, can tell you what the temperature is. And it's either handheld or there are ones you can put on a little tripod, a little mini weather station and put out there as well. It gives you great real-time data. And then you can take that data and look at using a chart or a app or something else or website to plug that data in and to get the evaporation rates. So we'll talk about that in a second as well. But the biggest thing is try to get that curing compound on within 30 minutes of texturing. It's literally pennies, per square foot. And so it's not expensive. And if it causes, if you spend that, you're saving yourself the chance of remove and replace, big time headaches, labor and time spent figuring out what went wrong and arguing with an owner. Nobody wants that for their concrete projects. So it's curing compound is the cheapest insurance that you can use because it's going to protect that surface during it when it's most critical, early ages, and give you the best chance for a durable surface. In addition to that, you could consider using a silane sealer. A lot of agencies we see using that, especially near the late fall, prior to our freeze thaw cycles starting and potential for salt being applied to a very young or green or freshly placed concrete to try to protect it, especially in the first winter or two. But it's a good idea for any concrete. If you want to protect your investment, it's another step from curing compound. There are some cure and seal combo products out there that are sprayed on in the curing compound side of things. As far as within 30 minutes, half curing, it's half silane sealer. Those are fine. They're just half as good as a full coat of curing compound, and they're half as good as a full sealer applied at a later age, but it's better than nothing. So those in general are our recommendations. There are lots of other products and chemicals out there that could work as well. Speaking of evaporation, this is the classic ACI chart. PCA has it in their Design and Control of Concrete Mixtures book, which is the concrete Bible to those nerds like myself in the concrete industry. And it's a nomograph. Again, as an engineer, we learned these in school. I did. Some of you may have seen them throughout your years as well. But you don't need a nomograph. You can use an app. I use the ACPA one, the American Concrete Pavement Association one. They have an app on their website that you just plug in the air temperature, relative humidity, concrete temperature, and wind speed. And it tells you what the evaporation rate in pounds of water evaporating per square foot per hour, technically from the concrete slab, but it was based on data from a pond. But at any rate, it's still what we use to this day. We know that 0.2 is always the critical number for shrinkage cracking. However, I've found in my experience, 0.1 is actually the number that we really need to pay attention to curing compound. Once you get down to zero evaporation, you can get away with, quote unquote, not curing your concrete because it means there's no wind and it's 99% humidity and there's no evaporation happening from the surface. Now, I say that, in air quotes that you can't see because you still need to cure your concrete in all situations and most specifications require it. And every issue that I see where there's a surface issue, typically no curing or lack of curing was the issue going on. So we'll go into that. But if you were to use the nomograph, 0.2, like that's the red line, but I find that 0.1 is actually more of a critical number. Here's a screenshot from that ACPA website. You just plug in your temps, your humidity, and your wind speed. It'll spit out your evaporation rates. So based on my experience, we've always had an issue with high evaporation rates, lack of curing, and it's typically causing scaling. I've looked at these. These are ones that I personally have been invited out to look at these projects in the last, well, these were from 2000 to 2022. And guess what? Those were all with Type 1 cement before Type 1L was implemented. So those that want to blame scaling on Type 1L, I say it's a factor, but we have scaling. We have always had scaling issues at times in our industry. And here's the data that show, and because these were high evaporation rate days, that caused issues. And primarily, in West and Southeast Michigan are the projects that I've looked at a few years ago. So I went back through my data and all the reports that I had produced for some of our members that asked for some of this assistance, and the pour dates listed, and we got weather station data and looked at evaporation rates. And yeah, most of the time when you have a surface issue, regardless of what's in the concrete, evaporation and lack of curing are the two things that go hand in hand. Does type 1L change some of that because it changes bleed rates? Absolutely. It is a factor, but it is not the primary cause. We've always had an issue with scaling. So let's dive into scaling. What is scaling? These are photos of non-type 1L concrete. This is from an older presentation from a couple of years ago that I put together. This is the loss of the surface mortar on top of the concrete slab surrounding the aggregate particles, essentially. The aggregate gets exposed, the mortar's peeled off. It's a physical action caused by weak paste on the surface, but it typically happens through the first or second or third winter, whenever we have a harsher winter. A lot of different factors go into that, but water can soak into that weak porous paste that did not get cured properly and had high evaporation rates right after it was placed. Water gets back into that sponge in the winter, and then it freezes, and water expands 9% in volume when it goes from liquid to solid, when it turns to ice. That's why it floats in your highball glass. That's why it floats on top of your ice fishing lake. It's the same weight, but is more volume, so it's less dense. So that expansion, 9% expansion in that weak surface paste pops it off and scales that surface off that 3 millimeters, eighth of an inch, plus or minus, a little bit. Depends on a lot of different factors how deep that'll go. But that's what scaling is. What is scaling affected by? Finishing practices? Yes, they will affect scaling. They could affect scaling. Finishing in the presence of bleed water. As the bleed water is coming up, or prior to the bleed water coming up, you could either seal the surface prior to the bleed water coming, and that can cause that delamination. Not as prevalent in air-entrained exterior concrete, but could happen. As it's coming up, I guess, that could happen too. You're elevating the water cement ratio as the water's coming up from the bottom, bleeding up through the slab, as everything else is settling out. Or you're applying water to the surface during finishing, increasing the water cement ratio, decreasing the strength of the paste, increasing its porosity, making it more of a sponge. Therefore, in the winter, it will then soak up that water and fail. Also, we see the use of steel trowels on exterior flatwork. I know some flatwork contractors swear by it and they've never had an issue, but guess what? With a new factor added to the equation, which is a slightly different cement than we've used in the past, you might get burned. And maybe just because you've gotten away with it in the past doesn't mean you're doing it right, even today. All right, what else can cause scaling? A weak or porous paste layer because of high evaporation. That cement particles don't have the water nearby them because it had evaporated, and that cement powder is just wasted and it's just sitting there, and it is a void then. If it's a grain of unhydrated cement in the surface, it has zero strength. And that's typically due to late or lack of curing application and high evaporation rates, and or a combination of something in between, as well as could be steel trowels on exterior flatwork, weakening that surface paste layer as well, even if it's properly cured after that finishing operation. Okay, so those are the factors involved. What do we do about it? Well, we feel as an industry, we need to educate concrete finishers. They need to understand that they are the most critical piece of the operation, the most critical cog in the wheel, that can influence the prevalence of scaling and the surface durability. So we've decided to implement a certification course called Michigan Concrete Association, MCA Exterior Concrete Finisher. You're a certified exterior concrete finisher if you complete this course and pass the exam, and as well as a performance exam. It is based on the National Ready Mix Concrete Association. They transpose the words and call it concrete exterior flatwork finisher, but we're just calling it exterior concrete finisher. It's based on theirs. That doesn't have an expiration date. Once you pass it, I guess it's a lifetime, but we're going to do a 5 year. And it's going to come, ours is going to combine primarily NRMCA with a Michigan focus, obviously, as well as some of the information from the ACI flatwork finisher that has on exterior. There are other options as well. If you don't want to go the certification route, we have implemented last summer, or sorry, this past spring, I should say, we started planning for it last summer. A concrete contractor 101, which is base boot camp type of thing, basic training, intro. We did a couple of 201 classes, had a lot of good discussion in those 201 classes. We're going to do those again this upcoming training season in the January to April timeframe. And there's other training out there. This is a screenshot from the NRMCA one that we're going to rely heavily on for our Michigan-based one. There are others. There's precedent for that. In the industry, your testing technicians obviously have to be certified for mixed design. We have our level 2 class for that. For decorative concrete, MDOT in their previously approved special provisions, they require at least one finisher have an MCA decorative concrete certification. We've done those classes for a number of years. There's precedent for that, all of that. These are examples of that. There are other ACI ones out there. We're just going to make ours Michigan-based for now and see where it goes. Self-consolidating concrete, that's a different type of testing procedures used to test that type of concrete. There's certain specifications, not MDOT, but does require concrete strength testing certification for breaking cylinders or other specimens. Speaking of specifications, we typically have very durable mixtures to start with. Concrete is a very durable product. And on the MDOT side, their specifications, they have pre-qualified ag sources. They have a lot of requirements on minimum cementitious contents, and they use a lot of the high performance and well-graded aggregates and all this stuff. And they have inspection as well, where they're making sure that this one-time water addition, once the truck arrives on site, but once placement begins, you're not allowed to add water back to that mixer because you can't you won't be able to calculate that water cement ratio. So that's not allowed on those types of projects. So also they typically get cured. MDOT construction specs require the white pigmented curing compound, 200 square foot per gallon if it's a square foot bid item, or 25 square yards per gallon if it is a square yard bid item like concrete paving. But that's typically enforced, and inspectors are making sure that that's being done. And especially on the big mainline highway jobs, they have a machine that applies it at a specified rate, and they can check that and make sure it's a good application. The issue with non-dot or I typically see light commercial and residential jobs particularly, they necessarily don't have written specifications, so they kind of default to industry standards, ASTMs and things like that, but there's not a lot of inspection on those jobs. So those projects that I showed earlier that were from around the state that had issues, surface issues, none of those had inspectors. None of them, I don't think, had much, if any, curing compound applied to them. And they probably would not have had the types of issues on all those projects if curing compound had been applied. They still started with good materials, but the care that was taken after that last texturing operation was done it fell short. Let's just be honest.
Steve, I'm going to just pause you here for just a quick second.
Yep.
We had a question about the MCA exterior concrete finisher certification.
Yeah.
When we were going to offer it and kind of what it was going to be, what it consisted of. So I just wanted to
answer that one, Heather?
Yeah, I will answer that. So the plan right now, this is actually a 2-part class. It's a book test, which will be an open book test similar to the MCA fundamentals. And then the other part of the class will actually be a hands-on demonstration of finishing skills such as jointing, edging, texturing, bowl floating, and curing. You have to demonstrate that you can properly do all of these things. So I anticipate that the book portion of the course, or you know, the in-class portion with the open book test, will occur later this year. Probably we'll have a session or two in the fall, and then we will do another couple sessions in January, February, early March. And then we will schedule a hands-on day, or depending on the way our contractors do this, we might actually go out to job sites and actually, observe and finish that portion of the certification at that point. So it'll be a kind of a two-part thing, because we're ramping this up as counties and cities and villages begin to adopt the specification. We need to kind of have a way of getting them through the book work portion first in the test, and then within 6 months, hopefully that will be the cutoff. Within 6 months, you have to have the hands-on portion completed. So that's hopefully answering the question for that. There'll be some more coming out on this as we continue to develop the course over the summer. I also have another question that says, Portland cement versus lime. What's the difference, and why did the switch only happen 3 years ago? Do you want to talk about that,
Sure. Yeah.
Steve, a little bit? And then
Yep.
as part of that, maybe you can open up the questions as well. Did the suppliers advise contractors to these changes?
Yeah.
And I would like to answer a little bit of that, because I just was in a national course that talked about these changes. And when this, and Steve, you can finish up, but when this was introduced, it was kind of introduced as a straight up one-to-one replacement. Like, you don't really need to do a whole lot of changes. That's the way it was introduced into the market 3 years ago. But as we know, that is not exactly what it is. There's some different things that happen to the concrete with this change in cement. So the suppliers let us know that it was happening, and then it happened. That's kind of the way this went. As far as why did the switch only happen 3 years ago, Steve, I will turn it over to you to finish that part up.
Yeah, we kind of talked about that at the beginning. It's a lower carbon cement per ton. And so that the cement companies, once one switched to it for environmental reasons and perhaps incentives. I'm not privy to the federal or other incentives that may have been in place at the time. But once one switched, many others followed. There is a lot of reasons, why we want to protect the environment, and we should. There's obviously a lot of concern with that, and I'm not advocating against that, but there's other reasons why, and it was allowed in specs. And actually, MDOT has allowed Type 1L cement since 2011 or for sure the 2012 spec book, but I saw it show up in a special provision prior to the 2012 spec book. So MDOT allowed it for over 10 years before they actually ever saw it. So, and I don't know if there were incentives, to do that, but it did happen. So, and as far as weak paste because of not having enough free water, that would be because of high evaporation. Typically, there's enough water in a mix as it's mixed and comes down the chute and is placed and consolidated and finished. There's usually adequate water for every cement particle in there. You just have to keep it in there. And so that's typically what is the case with that. So
when answering, I'm just going to piggyback on the answer to that question, Steve, is one thing we are noticing in some cases is that mixes like driveways and sidewalks that are being poured with a 3500 or a very lean cementitious mix, those tend to have more issues than the ones that are poured at a 4000 or 4500 that have a little bit more cement and a little bit more cement in them. Just a lot of times, sometimes they rubber stamp a 3500 for a driveway, and really we are recommending as an industry a 4000 or more. Just gives more forgiveness when finishing, as opposed to those other mixes. When we look at the data, It seems that the mixes that are struggling are very lean mixes placed in areas that are more hand finishing. So it's taking a 3,500 curb mix and using it also for a driveway or a sidewalk where they're wetting it up and making it a higher slump. So if you're going to pour it a little bit higher slump for driveways and sidewalks, make sure that you're using a 4,000, 4,000 PSI plus mix.
Yep. Yep. All right, let's finish up here, and we can still do some questions before we get to the full hour here. I will point you to an article that just showed up in my mailbox. I saw it online prior to that, but because ACI actually does the electronic publishing of their magazine prior to mailing it out to everyone, which is great. I just got the hard copy of this article, July 2025, Concrete International magazine. For all you ACI members out there, ACI, national members, you typically get this magazine every month mailed to your whatever address they have on file. But they had an article in there called Type 1L Cement and Concrete Scaling, and there's some good information in that article. I don't agree with 100% of everything that's in there, but there's definitely some very good, interesting points. My hard copy of it is actually highlighted a bunch of lines in there, and it aligns a lot with the things I've been saying here today. So there's also the National Concrete Consortium back in 2023 started seeing this because certain areas of the country saw Type 1L be implemented even before Michigan. Not that we're late to the game, it's just we were maybe at 6 months or a year behind some other places. And already in summer 2023, from the stuff that had been placed in 22 or 21 in the country, they had started seeing in freeze-thaw regions of the country, started seeing some potential scaling and initially being blamed on, a switch and just in general, scaling. Like I said, my data, I've looked at projects in my 20 years here in Michigan. I've always looked at projects, and the scaling rears its ugly head every once in a while, and sometimes worse than others. And it's all weather dependent, whether it's the dry, windy days when the concrete's being placed, or it's the severe winter that follows, or the really wet winter that everything's saturated and then gets a lot of hard freezes and pops. And there's lots of things that go on, but with the weather that we need to understand and try to counteract and react to with the material and how we place it. So, and then our MCA has a good concrete in practice document in their series, number 2, called Scaling. We reference that one all the time as well. Like I said, we've always always had an issue with scaling. We revamped our scaling brochure. It's on our website, PDF, technical bulletin, I should say, in July 2024. So a year ago at this time. And the prior version of it, just so everybody knows, was 2019. Was the last time we had revised it and sent it out and reminded people about curing your concrete. Don't overfinish. Touch it as little as possible. If you're using slag instead of fly ash now, which in 2019, that was what we had been seeing. That's different than fly ash, and if you have been using fly ash, that's different than straight Portland cement mixes. And so everybody needs to understand what is in my mix. Does that change how I need to finish? Does that make curing more critical? What's the weather today? Does that make curing more critical? And any change in the material in your mix is going to change a lot of different things that you can test. That also may change how you have to finish or need to finish that concrete. And there are adjustments we can do. So good news is I see a lot of good concrete. I know we talked about scaling a fair amount today. We talked about, do we blame finishers? Do we blame the guy who drops back to cure? Do we blame Type 1L? I'm not trying to assign any blame. I know we can all make good concrete. It's durable, long lasting. It looks great. You've got to start with a good design, good specifications that allow you the ability to actually get it done the way it needs to function properly. It has to be built properly, especially curing. I cannot stress that enough. If every concrete flatwork contractor in this state, decided to now cure their concrete every single time, regardless of weather conditions, we would rarely, if ever, have any surface issues with concrete. I firmly believe that. And so if I'm on my pulpit here preaching to the folks on this webinar, that's the one thing I want you to take away. Good
So
inspection. Go ahead, Heather.
we do have, a couple, a question on that recommending one of the things that we are seeing that the use of evaporation retarders are highly recommended, or finishing aids, either
Yeah,
integral or topical, are beneficial with type 1L cements.
yeah.
Um, are there any particular finishing sprays or aids that we
Go to your,
recommend?
I'd say go to your supplier and ask them what they have and give the different products a try.
Yep, there's all sorts of ones
There,
out there.
yep,
Because all of the suppliers are members of the association, right now we can't recommend,
no,
any one or the other. However, we do recommend using them, both
yes,
for as evaporation retarders and these finishing aids that are now, the topical finishing aids are showing a lot of promise when finishing as well.
absolutely.
Um,
And they don't preclude the need for curing. I'm surprised nobody's asked about integral sealers mixed into the concrete, at the ready mix plant. Those do not preclude the need for proper curing. They don't necessarily hold all the water in. Integral sealers prevent water from getting in the future when in the concrete's hard. So that does nothing for when it's still liquid and the water is allowed to evaporate from the surface before it's actually gone through initial set on the surface. So that's I'm anticipating that question on integral sealers. Is that going to solve all of our problems? It'll help concrete perform better long term by preventing salts and oils and whatever else to get into the concrete water, particularly to cause potential for freeze thaw damage. But we still need inspectors. I'll get to this third bullet point here under there, especially on jobs where there is inspection that needs to happen. Inspectors need to make sure they're doing their job to ensure compliance, curing compound is being applied. And then we need good maintenance. We need the concrete to be taken care of properly, maintained properly. If we mistreat it in the future and beat it up, yeah, it's going to show its age. So I'll get to a couple of these questions here. I see them popping up, Heather.
okay.
As far as can we determine on a scaled concrete surface, whatever it is, driveway, pavement, sidewalk, curb and gutter, whatever, is it materials or is it workmanship? The short answer is no, we can't always determine. But in most cases, in my opinion, the majority of scaling comes from lack of curing. It comes from evaporation from the surface. And in most of the studies that have been done and that have been communicated to me or I've looked at, and some are referenced in this ACI article that I just talked about that's in this recent magazine that just showed up, Concrete International. The petrographer that does it, and they note unhydrated cement particles at the surface causing a weak paste layer. Unhydrated cement, not enough water at the surface, and or elevated water cement ratio in some cases. In other words, water added to the surface and finished into the surface of concrete. So you can't determine that with a smoking gun, but in most cases, and I've told others this in the past, the contractors, the finishers, people in the field touching, placing, doing the concrete, the hard work, to be honest, they're the ones most in control of the destiny of that surface, of how it performs and how durable it is and its potential for scaling. So the answer is primarily workmanship. I mean, short answer is no, we can't determine for sure, but I would definitely say there is a need for us as an industry to train concrete finishers to do a better job. So, let's see, 2022 concrete that was placed in 2022 is reputed to be some of the stuff that's most affected. And I will say in Michigan, I believe that's when most of the type 1L cement switchover happened. Many of the producers, I believe, started in 2022 with that changeover. So that was when nobody knew that it was significantly different. And so a lot of the abuse that we typically do to fresh concrete and don't do it right, that was done still then. And we didn't know we would have a problem. Also, the winters are different. Every year I feel it's different. Sometimes we have a 1 week of cold temperatures and then not much else. Some years we have lots of snow, sometimes none at all. So temperatures, freeze thaw cycles, amount of snow, salt, de-icers applied, all that varies year by year. So I don't know why stuff from 2022 would be the performing the worst, but I do know that we've learned lessons every year since the implementation of Type 1L, and we are doing everything we can to educate. This is one example, but also to learn from our mistakes and change mixed designs and try to produce better concrete. So we've got a question on, is Type 1L here to stay? Are people going to revert back? I don't know. I will say changing an operation at a cement production facility to gear up to do this, I don't think can be easy to switch. So I don't know if they would want to switch back. I do know that there is some flexibility in the exact amount of limestone that can be ground in. So whether they dial it back, and you have to talk to the cement producers and see what their plans are, but I think there is room for dialing it back, but that's going to be on an individual company by company basis as to whether they choose to do that if their customers are demanding that. Are we going to go higher than 15%? I will say that's going to require a different specification altogether. That'll require the specifiers to move to an ASTM C1157 performance specification for cement, hydraulic cement. And that is generally not very common in the US yet. It is elsewhere, but it's rare that you would see that alone. Sometimes it's added as an option, but it's not always available. But that as a performance specification does not have as much prescriptive information on requirements, I should say, on the actual constituents and things in the cement. So I don't know if we're going to end up going to that as far as increasing amounts of limestone. I don't know if that's going to happen. I do think that cement producers are going to look at other options to include to lower their carbon footprint, whether they intergrind slag granules, they process some fly ash and put that in with their finished cement pre-blend or grind that into through maybe a reclaimed fly ash situation. Sorry, we can't call it fly ash anymore. ASTM calls it coal ash now. Harvested coal ash. So yeah, there's lots of different options, and the ASTM C595 specification allows for 1L, 1S, 1P. That's one with slag, one with pozzolan. P is pozzolan. That's coal ash. 1T, which is a ternary blend, which is the Portland clinker plus limestone plus another slag or pozzolan or something. So that's where I see the industry likely going. And hopefully in that push will mitigate some of the concerns that we are hearing or have seen with some of the implementation of Type 1L. So yeah, as far as durability and surface texture strength with Type 1L mixes, I know there's a lot of discussion, and there's a line in this ACI article about the potential during the bleeding, especially at high slumps, for different materials to work their way to the surface. Those lighter weight, inert, less, not as strong. I haven't seen that, or that's just discussion at this point. I haven't seen any data that proves that. I do know that in high abrasion situations, we're always going to wear off the surface. You looked at even old roadways that get a lot of traffic that have never even been diamond ground. You can see, wheel path wear where the tires have gone. It's not as bad as out west. For those of you that have been to the Pacific Northwest and have seen the studded tire damage on pavements out there, asphalt and concrete. At least we don't have studded tires in Michigan, typically. Not available in Michigan. So, but we do see surface wear on heavily trafficked surfaces, regardless of whether it's Type 1L cement or Type 1 cement. So, and as far as what the industry is doing with cement availability in our market, yeah, we see producers coming in and out of our market all the time based on supply and demand and price. So as far as where it comes from, we have no control other than, people telling us where they're buying the cement if we do ask and if they do want to answer. But I have no clue on the prediction of that. I do know with the Great Lakes, we can actively, easily bring in not salties, but at least Laker size freighters into the Great Lakes system, through the St. Lawrence River and all the way in the Great Lakes. We can also see cement supplies making their way up the Mississippi River corridor on barges, and some of that could potentially make its way this way. I don't know. I don't know what the
Oh,
future holds, but
Steve, I want to just pop in here quick to say, there's still type 1 and there's type 1L and there's type 1T, I believe, in the market currently. When working with any of these cements, yes, we're talking kind of specifically today about type 1L, but the reality is scaling can happen with all of them. These best practices haven't changed. So there might be you're going to get different cements from different suppliers all across the state of Michigan, depending on where you're at. It doesn't mean that we need to neglect when we're working with if you're working with type 1, that you neglect curing because type 1L is more susceptible to it. These are things that with all concrete, no matter what cement you're using, we have to be aware of and take caution and make sure we're, doing these best practices.
absolutely. Like I said, I've seen scaling over 20 years working in Michigan. It's always been an issue that crops up at times for various reasons. And it's not just the cement its fault. And it's contractors and finishers are the ones that have the most control over whether it occurs or not. Lastly, let's end on a positive note. We've helped fund this new program at Lawrence Tech on concrete technology and management. So if you know anybody that's interested in getting a 4-year bachelor's degree in concrete, it is available to do that in Michigan. We heavily support it. There's scholarships available. If you know any high schoolers that want to get into the construction industry, maybe aren't as sharp or not interested, on the engineering side, I guess that doesn't really float their boat, but the construction side does. But they do want to go to college. This is potentially an option. So it's my little blurb on featuring that program at Lawrence Tech. And then lastly, we'll just finish up with my contact info. Please reach out with any questions, comments, concerns, and I appreciate everybody's time today.
We don't have any other questions. So thank you, everybody.
Appreciate it. Thanks. Take care.